Hey guys, in today's video we're going to look at the GeeksForGeeks question of the day, reverse k elements of a queue. So in this question we are given an integer k and a queue of integers. We need to reverse the order of the first k elements inside the queue, leaving the rest of the elements in the same order. We can perform any of these operations, that is to add an element to the rear of the queue, remove an element from the front of the queue. So these are the basic first in first out. So imagine a queue where you enter from the end and come from the top. So you add an element from the end and remove from the top. So these are the two operations, and this is the size of the queue and this is the front element of the queue. So let's take a few examples and see how we can solve this question. So this is the k value equal to 3 and these are the elements inside the queue. So 5 is the size. So if we take the queue 1, 2, 3, 4, 5 and these are the first k elements. So we need to reverse them. So after you reverse them, first k elements are 3, 2, 1 and 4 and 5 remain the same. So this will be the output which is matching here. Similarly, k is equal to 4. Let's write the queue elements 4, 3, 2, 1. K is equal to 4. So you have to reverse all the 4 elements. So after reversing, the output is 1, 2, 3, 4, which is the expected output here. So as you know, we have to remove k elements first. For that we can use a stack. Remove and place these 4 elements inside the stack. And then we have to pop these elements from the stack. So the stack will contain these 3 elements. So we pop the elements from the stack one by one and add it into the queue. So here you can see we add it into the queue. And here we are removing the last 2 digits. For this example, rem length is equal to 2 because we calculate the size of the queue. 5 minus 3 is equal to 2. And we add those 2 elements to the queue again. So we remove them and add the elements into the queue. And finally we return the queue as the output. So let's take an example and see the dry run of this code. So I've taken the same example given to us. The queue elements are 1, 2, 3, 4, 5 as this example, and case value is 3 and case value is 3, and this is the same function which we are going to submit. So this function will return a queue after modification, and I'm catching that inside this result and printing it as the output. Now let's debug the code. I place few breakpoints, one here, and one here. Now let's debug the code. Now here, as you can see, there are 5 elements inside the queue. 1, 2, 3, 4, 5 starting from index position 0 through 4. K is 3 and stack is initially empty, we just created here. Now we have to remove k elements from the queue. K is equal to 3, so we have to remove these 3 elements from the queue and add it into the stack. Q.remove will pick the 0th element, that is the front of the queue, and it will add it into the stack. So stack will be added with 1. So here, as you can see, one element has been added into the stack, that is 1, and from here the element 1 has been removed from the queue. Now case value will be decremented by 1 because we removed one element. Now k is 2. Now this element will be removed and added into the stack above 1. So here, as you can see, 2 has been removed and added into the stack. Next case, again k will be decremented. Case value is 1 now. Now it will remove this element and add it into the stack. So here, as you can see, 3 has been removed and has been added here. Now k is equal to 0 and this condition will fail. So we come out of the while loop. Now queue has 4, 5 and stack has 3, 2, 1. Now we have to pop one element from the stack and add it back into the queue. So 3 will be removed and added into the queue. So 3 has been removed from here and has been added at the end of the queue. Now again 2 will be removed and added at the end of the queue. Here, as you can see, 2 has been added here from the stack. Now again 1 will be removed and added at the end of the queue. Now the elements are 4, 5, 3, 2, 1, which is pretty close to our expected output. 3, 2, 1 is there. So 4, 5 should come in the end. It is there in the beginning for us. 4, 5 is in the beginning. So we have to remove these 2 elements. How are you going to know how many elements you have to remove? You calculate the size of the initial queue, which was 5. Number of elements to be removed were 3. So 5 minus 3 is equal to 2. Correct, right? So this is the first 5 elements. You remove 3 elements. So 4 and 5 are the original elements at the end. So you have to remove those 2 elements and add it at the end. So I'm removing the element from the front of the queue and will add it at the back of the queue. So here, as you can see, 4 has been removed and added at the end. Now rem length will be decremented by 1. Now we have to remove one more element. 5 will be removed from the beginning and will be added at the end of the queue. So 5 has been removed and added at the end. Now rem length is 0. We processed all the elements and finally we have our output 3, 2, 1, 4, 5. So which is the expected output here. Now this function will return queue because this is the return type as expected here. This is the return type. It will return a queue and it will be caught inside the main function. We are calling it here. It will be caught inside result. I'm iterating through the result queue and printing one element at a time. So let's see how the result is being built. And finally, all the elements will be printed. So this is the final answer, 32145, which is the expected output here. So the time complexity of this approach is O of n, and the space complexity is O of k, which is expected here. That's it guys. Thank you for watching, and I'll see you in the next video.